yesterday we started talking about polar form, which is different. It's used to represent complex numbers. We're used to a plus bi form, which is called rectangular form. Polar form puts sines and cosines with that. And so we talked about how, in cosine was x over r, sine was y over r, and so we developed this rectangular or polar form equation. And so then we had a problem where I gave you the polar form, we had to turn it into rectangular, which was pretty straightforward because you just evaluated and multiplied out. So now we're talking about how to go the other way. If I start with a plus bi, how do I get the sines and cosines and put it into polar form? So first we have to draw a graph. That way when we get to step 3, finding our angle, we know which quadrant we're in so we can get the correct angle. Then we find r, which is really just the magnitude, just like we were doing when we talked about vectors. And then we find our theta, which is just like we did with the vectors. Tangent is b over a, or y over x. So let's look at some problems. I could do these in either radians or degrees since we're finding an angle, so I just put one up of each so we could practice that. So if I wanted you to put this into trig form or polar form, I could say either way. That means you're doing the r times cosine theta plus I sine theta form. So we start with kind of drawing this so we can pick our quadrant. Your picture doesn't have to be real exact. Like I said, it's really just the purpose of having a quadrant. In this, we talked about we have a real and an imaginary axis. Do you guys remember which is which?
Imaginary is the
Good. So the negative radical 3, that's my real part, that's my x. So it's like traveling backwards a radical 3. Then the imaginary is my I, or just a 1, so we go up 1. So not exact at all here, but just kind of gives me a rough sketch so I know I'm in quadrant 2 when I'm doing this. So we need to get our r, which is just like finding the magnitude, if you think of it as a vector. Square root of a squared plus b squared. We can think of this as like a triangle. The side was negative radical 3. You go up 1, so a Pythagorean theorem type thing. Either way, when I plug this in, so my x was a negative radical 3 squared. My y, we are just doing the coefficient on the I, so that would be a 1 squared. So the square root of 3 plus 1, so square root of 4 is 2. So my r is 2. Now we need our theta. So tangent is b over a or y over x. Y is just your coefficient on your imaginary, so that was a 1. My x was my real part, so negative radical 3. Come on in. Get the radical off the bottom. Oh, sorry. So tangent is negative radical 3 over 3. We don't need a calculator for this. We should know. Radian measure. Which quadrant are we in?
2.
Reference angle. When is tangent radical 3 over 3? Which angle is that? 30 degrees, which in radians is pi over 6. So my angle, pi over 6 in quadrant 2 would be 5. So the final answer, my complex number is, or my polar form, my r is 2 times the cosine of 5 pi over 6 plus I sine 5 pi over 6. When you write the trig or the polar form, you leave the sines and cosines. You don't evaluate them. So that is our answer. Is that okay? Let's look at B. So if I am going to look at this, negative 3i. So it's like x plus yi. So in this case, there's no real number. So it's like saying my x is 0 and my y is negative 3. So if I'm going to graph this, we have a 0, negative 3. So this is what negative 3i looks like. So then we find r, square root of x squared plus y squared. We get the square root of 9, which is 3. We need our angle. Tangent is y over x, negative 3 over 0 is undefined. So it's like asking ourselves when tangent is undefined, or we can look at our picture and we should kind of be able to see what is our angle here.
2 7.
So then my form will be r times
So 3 times the cosine of 2 negative 7 plus I sine of 2 7.
and that would be our final answer. Is this okay? Alright, do we need more examples of any of this stuff? So I have a handout for you.